All right, welcome to lesson 7, lines and angles. I'm excited about this one. I just love geometry, so I hope that this is informative for you. Today's going to be a lot of definition-y kind of stuff as far as geometry goes. So, lines and angles, we're going to get right into it. Basic building blocks of geometry are called points. A point is an infinitely small space. So we label points with a dot, but that doesn't mean that that dot is the exact width of that point. It just represents this infinitely small thing. And we label them with capital letters. So point A, point B. You can only have one point A or point B in any given plane, so I can't write another point A. I'd have to label it with whatever other letter I wanted. Lines. In between any given points, there exists a line. So this would be line DC. Notice lines have, I know that's kind of small, but there's a little arrow on either end. So lines extend infinitely in either direction. You can name lines two different ways. Because they go in two different directions, the order is not going to be important. So I could call this line CD or line DC. Does not matter. When you name it, though, you have arrows on either end of the line that goes above it. You should be writing all this stuff down in your notes. There's nothing gluing in today. We're just copying what you see here. So that's your lines. Line segments are going to be another important thing. Line segments, instead of extending infinitely in either direction, line segments have an end point. So this is the segment between F and E. I can measure that distance, so sometimes we'll talk about what the length of the line segment is, where you can't really do that with a line because it goes on forever. For line segments, similar to lines, you can name them in either order. Notice that there is no arrow on either end above the EF and the FE. Again, something that you need to write down in your notes. Pause the video if I'm going too fast. Rays. Rays are kind of a combo between line segments and lines. So for a ray, you are going to see something where it goes off infinitely in one direction. So I have an end point K, and it goes off infinitely in the J direction. Here I have an endpoint G, and my ray goes off infinitely in the H direction. When you write rays, the order now is important where it hasn't been important before. When we write rays, we're going to start with the endpoint and end with whatever direction it's going in. So this one would be ray KJ. The next one, you might be inclined to say HG, but we're starting with G and going in the H direction. So you need to write GH with that ray over it. Sometimes I've gotten the question, well, could I write it this way? Could I write HG, but then put my arrow going that direction? Answer is no. That is not a standard way of writing a ray. I get what you mean, but that is not the way that we write rays. Inside of any line, you can talk about a line segment. So if I have this line, I could refer to just any smaller piece of that line, and that would, so like this would be line HP, or you could call it line HS, or line SP, or line PS, or PH. All of those are fine if you're referring to the line. But what if you just wanted to talk about that line segment within the line? Totally fine. You could refer to that segment just as HS with the line over it. Or, alternately, you could refer to that as SH. So inside any given line, there are also line segments. Or you could talk about segment HP, and that would indicate that what you're talking about ends at H and ends at P, rather than going off into any direction. Yeah, so there are line segments within lines. Also wanted to talk about this situation where you've got a line, you've got 3 points on the line. Well, what if we knew that SP has a length of 10, and we know that HP has a length of 16, so the whole thing is 16. Again, I do want this in your notes, so go ahead and sketch out this situation. How would you figure out the length of HS? Well, if I know the whole thing is 16, and I know that this chunk of it is 10, figuring out HS, well, that shouldn't be too bad. All we need to do is take the whole thing and subtract out this section, and we'll be left with the HS. So I need 16 minus 10, and I'm left with the fact that HS is equal to 6. So HS is equal to 6 up here. That property, that's an important thing in geometry. That's called your segment addition postulate. You don't need to know the name, but you need to know the concept. This little m, it stands for measure. It means how long it is. So the measure of HS, so this section, plus the measure of SP, so the other smaller section, is equal to the measure of HP. So the little segment plus little segment together gives you the larger segment, the whole thing. Other vocabulary you will need to know, again, should be something you are writing in your notes. Intersect. Intersect means that your two lines are going to cross one another. So something like this would be an intersecting line, and they intersect at point Y. So this would be called the point of intersection. Parallel lines. I'm sure you've heard of them before. Parallel lines extend infinitely in the same direction. They never intersect one another. The symbol for parallel lines, this is the part that you definitely need to know, that those two lines right here, that indicates that line PQ is parallel to line MN. So that's what that symbol means, to indicate that those two lines are parallel. Or not opposite of parallel, it's something different than parallel. A specific case of intersecting would be perpendicular lines. Perpendicular indicates that those lines intersect, and they intersect at right angles or 90-degree angles. That little box in there indicates that it is a 90-degree or a right angle. The symbol for perpendicular looks like this. And that makes sense. I mean, these two lines obviously are parallel to each other. They intersect at right angles, so it's kind of intuitive, I guess, what this is talking about. But so it says US, so line US is perpendicular to line TV. And we know that because we got that little box in there. So sometimes they might ask you what is perpendicular to what, or what line is parallel to what. All right, so that's some general vocab. The last bit of vocab, angles. So angles are when you've got two rays that come out of one point here. And so this point, it is called your vertex. So here G is my vertex, and so I do want you to know the term vertex. So G is my vertex of that angle. You can name angles a lot of different ways. So we go in order. So I'm going to say angle BGR, but I could also say angle RGB. As long as G is in the middle. That is important. G has to be in the middle when you name your angles. So BGR, RBG. I could also just call this angle G. I'm not always going to be able to do that because sometimes you'll have situations where there's another ray coming off it, and it wouldn't be very specific. You wouldn't be able to tell which angle you were talking about. But in a situation like this, where there's only one angle coming out of point G, I could call it angle G. You could also call this angle 1. Sometimes there'll be a little number in there. Not always, but sometimes. So for this one, I could call it angle 1. This guy. This is a situation where I can't just say angle K because I could be referring to this angle if I talked about angle K. I could be referring to this angle if I talked about angle K. Or I could be referring to the entire angle if I talk about angle K. So I can't just say angle K. You would have to say angle JKL if you want to talk about the whole one, or if you want to talk about this smaller one, angle LKM. So I just wanted to show you an example where you cannot name an angle with just one letter. This one, you'd have to name whichever angle you're talking about with 3 letters. All right. You should have heard this vocabulary before, but if you don't, I would definitely go write that in my notes. If you know it, I would not worry about it. Acute angles are when your angle is less than 90 degrees. Obtuse is the larger angles. They are greater than 90 degrees. Right angles look like this. You'll often see a little box in there. Straight angles technically are equal to 180 degrees. They're a line, but sometimes they can be referred to as straight angles. All right, almost there. I want you to go ahead and pause the video and answer these questions. You do not need to copy this figure down. You don't need to copy the question down, just 1 through 6, and write your answer into the question. Go ahead and pause your video. All right, hopefully you have answered numbers 1 through 6, and I'm going to go ahead and show you the answers. Line DF is parallel to line AB. DF, I could have also called it line DE or EF, but you just have to pick one. Segment EB is perpendicular to 2 different lines. You could have either said that EB is perpendicular to DF, this top line, or it is perpendicular to AB. So if this guy has the little box there, then this one also will have the box there since I know they're parallel. An obtuse angle. We only actually have enough information to name one obtuse angle. So angle ABF. So, whoa, okay. So angle ABF, this angle is an obtuse angle. So I need to go ahead and label that one. This one up here also is an obtuse angle, but I don't have a third letter, so I was not able to name that one. So we're just going to go with ABF. You could have also called it FBA. An acute angle. So if I want an acute angle, there's 2 different options. So you could have had angle EBF, that would be this guy. You could have also said angle EFB, that would be this guy right here. This one also is an acute angle, but again, I don't have a third letter, so I can't name that one. So it needs to be one of those. A right angle, there are 3 different right angles that you could have talked about. You could have talked about DEB, so this one right here. You could have talked about FEB, so that would be this one right here. And you could have called ABE, this one right here. And again, you could name those backwards. BED, BEF, EBA, all would work. And then I also wanted to make sure we knew what a vertex was. So the vertex of DFB, well, DFB is this angle right here, same thing as EFB. And my vertex is this point right here, so point F. You could have also gotten that from just looking right here. The middle point is always going to be your vertex. All right, congratulations, you are done.